Okay, so in this topic we'll study about motional electromotive force. So motional electromotive force. So we know electromotive force is also called as EMF. Electromotive force is also EMF. And motional represents the change in distance of an object. So when an object moves, there will be an induced EMF on that object. So that is the main concept of motional electromotive force. So in this we'll study about how change in motion of an object can lead to change in magnetic flux, which will induce EMF, and we'll find the formula and yeah, all that. So now first, for that we'll make the same diagram of this diagram on our book. So imagine this is our conductor PQ, or a coil, or it can be anything, and we place it on a rectangular rail. This is a rectangular layer, and it is set like that this PQ can slide across this surface. Let's call this as R and this as S. So this PQ can slide and go towards RS. So it can move towards RS V. And let's call this length of the rod PQ as L and this distance as X. So now we know that magnetic flux is equal to BA cos theta. B is magnetic field, A is area of the coil or circuit, and cos theta is the angle between B and A. So now magnetic field, will keep it as it is because we don't know much about magnetic field. So B, and then area. So we will take this as one circular coil, circular or closed coil. So in this closed coil, we know it's a rectangle. So it's the area of rectangle, length into breadth. Here what is the length? L. And what is the breadth? X. I mean X is the breadth and L is the length. And cos theta, this is in the same direction of the coil, so we'll just take it as cos 0. So BLX, cos 0 is 1, so we'll just take it as BLX. So now when we take this rod and when we slide it through the surface, so slide it, so at some interval it comes over here. So this rod comes at this position. So now we know X has changed, right? So now we know X has changed, and L is same, B will be same because we didn't change the magnetic field nor we change the length of the rod. The rod is same, just the X or the distance between S and Q changed. So we'll put B as it is and L as it is. And to represent change of a object, we will say change in distance, which is dx, over change in time. So in this amount of time, this much distance displaced. So from here to here, the length changed from x to something. Let's say from x minus y. Okay, leave this. No. Okay, so I think you understand till here. BL dx by dt. BL is the magnetic field, L is the length of the rod, and dx by dt is the change in direction of this rod. So this rod from this position came from A to B. So the change in distance is change in distance by time, because we are observing this in time t. So now we know dx by dt. Dx means distance and time, and this is, we can also call it as displacement because it's the same thing. So we know displacement by time is velocity. So B L V, because distance by time is equal to velocity. So once we imply this, we get B L V. And now this is for magnetic flux. So therefore, to find magnetic flux, this B represents magnetic flux. So now we know change or the value of magnetic flux when a rod is moving is BLV, where B is the magnetic field, L is the length of the rod, and V is the velocity at which this is moving. Because why the magnetic flux will change? Because example, the magnetic field lines were passing all of this area, like this, all of this area. You see, now this much amount of field lines are passing, but if I bring this rod over here, then in this it has reduced, the magnetic flux has reduced. Why it has reduced? Because less amount of magnetic lines are going inside. So because less amount of magnetic lines are going inside, the flux will reduce. So now the flux is changing, right? So first it was this much, then it became this much. The flux is changing, therefore it will induce EMF. Okay, so over here, as we are changing the position of the rod was first at position A, and now this has become to position B. So the position of the rod has been changed, right? So therefore it was in motion. So this is known as motional EMF. Why? Because this rod has been changed. We change the magnetic flux, and we know change in magnetic flux by time is EMF. And how this EMF is formed? By the motion of this rod. By the motion, the EMF has been induced. So motional EMF. So this was one simple way of determining the value of magnetic flux if the rod was moving. So the second way is this way is called as this way or method is like Lorentz force method. So we studied in chapter 4 or chapter 5 that Lorentz force is the combination of electric force and magnetic force. Means the electric field lines, the force created by electric field lines, and the force created by magnetic field lines. So it is a sum of electric field lines and the magnetic field lines, the force, the sum of the force. So we know the formula for it is Q V B, where Q is charge, V is the velocity, and B is the magnetic field. So now we know what is work done. What is work done? Force into displacement, or displacement or distance, same thing. So Lorentz force is QV. Okay, so if the force is QVB, and the displacement, so let's imagine this is a rod, again same rod, PQ, this is rod PQ, and it has moved some distance L. It has moved some distance L. This distance is displacement, so we call it as L. Okay, so now we know work is equal to QVB L. Now we know velocity is equal to EMF, right? So V is equal to EMF. So I hope you could see before this thing. Okay, so V is EMF, and velocity is work by charge. Search in Google. Google for reference, or you can search in Google, or also you can go to this page. Wait. This is the current electricity chapter, page number 126. It has this box. It has about formulas and all. So from here we know voltage V is work by charge, and electromotive force is also work by charge. They both are the same unit and the same dimension also. Therefore V is same as electromotive force. Just the symbol is different because we have to determine what is voltage and what is electromotive force. Otherwise it's same thing. Okay, so we know from that page, we know V is equal to W by Q. So which means E is also equal to W by Q. So what is work here? What is work? QVB. QVBL and Q. Already next page. If is equal to QVBL by Q. Now we can cut Q, right? We can cut. And now what is electromotive force? VBL. Or if I arrange it well, it will be BLV. The same. Where is it? Yeah, the same. This is same. So B is magnetic field, V is velocity, L is the length of the rod. Okay, my bad. Length of the rod. Okay, I'm sorry. L is the length of rod, because work is done to this entire rod, right? Entire rod. So we have to determine about this entire rod, not about this one piece. So entire rod, so we'll multiply it by length. Yes, force into displacement is same thing. No, wait, not displacement actually. Length. Work is equal to length. Okay, my bad. Same thing. You can search up in Google also. If you search, it's the same thing. So now we found this BLV through Lorentz force method. So next topic over here, you see we covered this by Lorentz force, and then we found this, and then nothing much. Yeah, that's it. That's electromotive force, and the topic is over, finished. And next we'll talk about energy consideration, a quantitative study. So this is just put in random formula. This is not much topic. This was the topic to study, and here we'll just take this formula BLV. We'll take this formula BLV and then substitute it almost everywhere we know about electricity and energy and all. So first, we know V is equal to IR, right? Then I is equal to V by R, right? We take this R over here, right? We can. Okay, now good. So we know what is V. V is equal to EMF, right? So I is equal to E by R, right? So the current, so what is I? Current. R is resistance, V is EMF. So current, or the current flown in that induced current flowed in that coil is what we have to find. So I is equal to, what is E? BLV by R. So this is formula to find current in the loop. This is the current that we flowed purposely, like we want to flow. EMF is the opposed or induced EMF or induced current. This is the induced current, this is the real current we flowed. Okay, so to determine the value or the magnitude of the real current, induced current divided by resistance. That's it, easy. So now, what will be the force due to this induced current? Force due to induced current. Force due to induced current. What is force? Force is equal to ILB. This is force due to magnetic field. Okay, remember, magnetic field. Why about magnetic field we are learning? Because magnetic flux we are learning in this chapter. So it's magnetic field. And what is I? BLB. BLB by R. What is L? L. What is B? B. So multiply this and multiply this is equal to B square L square V by R. Okay, so this is R. B square L square V by R. How we found? We know what is force due to magnetic field, ILB. We studied this in magnetism chapter. Force equal to ILB. I is the current, L is the length, and B is the magnetic field. So what is I in this formula? What is I? What is I? BLV by R. So we substitute BLV by R into L into B. L and L is same, so square. B and B is square, B square, and V down here. And then divided by R, divided by R. So that's force due to induced current. There will be a force due to induced current. Why? Because it's producing another magnetic field. So every current produces a magnetic field. So induced current will also produce a magnetic field, and we know magnetic field will create some force. That force will change the direction of the charge. So it's all linked all together. So that's why we have to know about the force. So there will be a force experienced by whatever object is near, or the current is near, or charge is near in that circuit or coil. So next we'll study, or next formula is about power. We know what is power. What is power? Power is work by time. Yes, power is work by time. So what is work? Force into velocity by time. And is equal to force. And what is velocity by time? By force. Okay, so work is force into velocity, right? And we can expand this work as force into velocity by time. So now we take force into V by time. We can take this because we can just separate them, doesn't matter, it's multiplication. So what is velocity by time? What is velocity by time? Wait, it's not velocity. I messed up. Okay, I'm sorry. New page. Happens. Okay. So power is equal to work by time, right? So what is work? Force into displacement. Work is force into displacement. So P is equal to F into D by T. So if I leave force alone, force into D by T, displacement by time. What is displacement by time? Velocity. So P is equal to F into velocity, right? So now if I take force has, what is the force which we got here? BL, B square L square V into R. So B square L square V into R into, what is there? V. So V multiply, P is equal to B square L square V square by R. So this is another expression we found to find in power. What power? So what power we are finding? So this power, like this is that rod we were doing here, right? This is this rod or this rod, right? And we were sliding this rod. So the power taken to slide this rod, is, if you have to find, is by this. Because of course the rod cannot move by itself. We need to apply power or force. So this power applied is this. And now this is by finding force into displacement. This is one method. The second method is, look, we know we put mechanical energy, right? We change this rod manually, means we put our mechanical energy, and this mechanical energy is stored somewhere. or it's converted somewhere. What happens with this mechanical energy? So when this mechanical energy is there, electric field is produced, means it turns into electric energy, and this electric energy, it will also decompose, it will become heat energy. So electric energy will be released as heat energy, which will be released as heat. So this power will be released as heat. So we know what is heat, joules, same thing. So this power will be released as joules. So power of joules, you can also search it up. The formula is I square into R. Okay, I square into R. What is I? Search it also in this Google. Okay, it's kind of, so you like to understand maybe. So what is I? Where is I? BLV by R, the whole square into R, right? So it's equal to B square L square V square by R square into R. R we can cut. So what is that? B square L square V square by R. Same formula is found here, right? So now we can conclude that mechanical energy over here, mechanical energy is same as heat energy. So this mechanical energy is released as heat energy in the end of this process. And there's the expression to find power. And in this final expression, we can know the magnitude of induced EMF. So how to find EMF? Wait, not EMF. Charge. We can find charge, or the total charge, or the amount of charge, somehow with EMF. So first we'll do that. We know what is EMF. What is EMF? Change in flux by time, right? Change in flux by time. And we know E is also equal to IR. How? Because V is equal to IR, right? V is same as thing. So this I can just relate it into this, and this whole thing I can put it as this. Easy. Okay, so I can substitute this over here. I can put this over here. So IR is equal to Q by T, right? What is I? What is I? Q by T. Current. What is I? Current. What is current? Charge by time. Charge by time. So I can substitute that over here again. So Q by T R is equal to flux by time. I cut this. What is left? Q. Okay, or flux. Oh wait, no. Q is better. QR is equal to flux. So Q is equal to flux by R. And this is the last expression of this topic. So Q is equal to flux by R, or we can also determine change. You know, it's same thing. Change. This triangle means change. So change. Everywhere just change. Okay. So changing current or changing charge is equal to change in magnetic flux by R. What is R? Resistance. And this is the last expression of this topic, and the topic is over. Yes, and there's one mistake I made it over here. Just one mistake over here I made it. Just please be careful. And one thing over here. Okay, my bad. I'm sorry. Thank you so much.